In this exercise, we want to study and to design a heat recovery heat exchanger. So we are in a food factory, and there is a flow of hot oil, cooking oil that needs to be cooled down in order to be stored. And also there's a need to have hot steam, water steam, for cleaning processes and for sterilization. So the idea is to recover heat from the cooking oil in order to heat up water, so liquid water in ambient conditions, to heat it up to saturation, then to evaporate it completely, and then to superheat the water vapor. The heat exchanger that we want to use for this application is a double pipe heat exchanger. So you have two pipes, one is in the other pipe, and we have a counterflow in one direction. So here in the annular section we have the oil entering in inlet condition with 170 degrees Celsius and volumetric flow rate of 110 liters per hour. And in the other direction, so in the tubular section, in the inner tube, we have the water that is entering liquid at 1 bar and 20 degrees Celsius on the other side. So the objective here is to produce a water vapor at 140 degrees. On the water side, we will have three different steps in terms of heat transfer. The first step, where the water will be heated up to saturation, so from D to C. Then from C to B, the water will completely evaporate around saturation temperature. And once it is totally vapor, then the water vapor will be heated up to 140 degrees at its outlet A. And on the other direction, the oil which is entering at 170 degrees Celsius will be cooled down to a given temperature that we need to find. So the first part of this exercise is to see if it is possible to produce up to 2.55 grams per second of water steam at these conditions with the flow of oil that we have. And then in the second part we will do a proper design of the heat exchanger in order to calculate what length of heat exchanger is needed to do this operation.